Electrical problems are no joke. A faulty wire or a malfunctioning appliance can spell disaster, leading to anything from a blown fuse to a full-blown fire. That's why electrical fault finding is so crucial. It's about keeping your home safe and your electronics humming. Think of it like detective work. You're looking for clues, tracing wires, and using your knowledge to pinpoint the source of the problem. It's not always easy, but with the right know-how, you can tackle most common electrical issues. Now, I'm not saying you should start rewiring your house after reading this essay. Leave the big jobs to the pros. But understanding the basics can help you troubleshoot minor problems and maybe even save you a call to the electrician. Remember, safety comes first. Always disconnect the power before working on any electrical system, and if you're ever unsure about something, don't hesitate to call a qualified electrician. Before you can find a fault, you need to understand how electricity flows through a circuit. That's where electrical diagrams come in. They're like roadmaps for your wiring, showing you where everything goes and how it's connected. Diagrams use symbols to represent different components like switches, outlets, and wires. Think of them as the letters in an electrical alphabet. You'll see things like straight lines for wires, zigzags for resistors, and circles with crosses for light bulbs. Learning these symbols is key to reading a diagram. Once you know what each one means, you can follow the flow of electricity and start to see how the circuit works. It's like learning a new language, but trust me, it's a lot easier than French. There are tons of resources available online and in libraries that explain these symbols in detail. Take some time to familiarize yourself with them, and soon you'll be reading diagrams like a pro. Just like any trade, electricians have their own set of symbols in shorthand. Don't worry, you don't need a degree in electrical engineering to understand the basics. We use symbols for things like voltage, V, current, I, and resistance, R. You'll also see symbols for things like ohms, omega, which measure resistance, and watts, W, which measure power. These symbols aren't just for show. They help us calculate how electricity will behave in a circuit. For example, we can use Ohm's law, V equals E times R, to figure out the voltage, current, or resistance in a circuit, which comes in handy for troubleshooting. Understanding these symbols is like having the right tools for the job. It lets you make informed decisions about your electrical system and helps you communicate more effectively with electricians. Let's talk about light bulbs for a second. They're a great way to visualize how electricity works. Imagine a simple circuit with a battery, a switch, and a light bulb. When the switch is closed, electricity flows from the battery, through the switch, to the light bulb. Voltage is like the pressure pushing electricity through the wires. Higher voltage means a brighter light bulb. We measure voltage across components in a circuit. Low voltage might make the bulb dim or not light up. Understanding voltage is crucial for diagnosing electrical problems. Now, before you even think about touching a wire or opening an electrical panel, let's talk safety. Remember, electricity is dangerous and can be deadly if not handled properly. That's where lockout procedures come in. Lockout is a safety protocol used to de-energize electrical equipment before working on it. It involves shutting off the power at the breaker box and physically locking the breaker in the off position. This ensures that no one can accidentally turn the power back on while you're working. It's like putting a safety net around yourself. Always use a lockout tag to clearly label the breaker and indicate that work is being done. Never, ever work on an electrical system that is live. Always follow proper lockout procedures to protect yourself and others from electrical shock. Circuit breakers, guardians of your electrical system. Circuit breakers are your electrical system's safety net. They trip to cut off electricity if there's an overload or short circuit. This prevents damage and reduces fire risk. Different breakers serve different applications. Type B for homes, Type C for higher currents. Each breaker is rated for specific amperage. Using the wrong breaker can cause tripping or fire. Consult an electrician to ensure proper protection. Section 7. Distance matters. Choosing the right cable for the job. When it comes to electrical wiring, distance matters. The longer the cable run, the greater the voltage drop, which can affect the performance of your appliances and electronics. Using the wrong cable size for the distance can lead to overheating, voltage drop, and even fire hazards. That's why it's crucial to choose the right cable for the job, taking into account the amperage of the circuit and the length of the run. For longer distances, you'll need a thicker cable with lower resistance to minimize voltage drop. Your electrician can help you calculate the correct cable size based on the specific requirements of your installation. Remember, using the right cable isn't just about performance, it's about safety. A properly sized cable will ensure that your wiring stays cool, your appliances receive the correct voltage, and your home remains safe from electrical hazards. Section 8. Key electrical components. Understanding the building blocks. To truly master electrical fault finding, it helps to understand the basic building blocks of an electrical system. Here are a few key components. Switches. These interrupt the flow of electricity, allowing you to turn circuits on and off. Outlets. These provide a safe and convenient way to connect appliances and devices to the electrical system. Junction boxes. These enclose electrical connections, providing a safe and organized way to splice wires. Ground fault circuit interrupters, or GFCIs. These special outlets protect against electrical shocks in wet locations like bathrooms and kitchens. Arc fault circuit interrupters, or AFCIs. These devices detect and interrupt dangerous arcing faults that can cause fires. Understanding how these components work and how they interact within a circuit is essential for effective troubleshooting. By familiarizing yourself with these building blocks, you'll be better equipped to identify the source of electrical problems and make informed decisions about repairs. Section 9. Safety first, always a final word. Mastering electrical fault finding is a valuable skill, but it's crucial to remember that safety should always be your top priority. Electricity is a powerful force that demands respect. Never work on an electrical system without first de-energizing it using proper lockout procedures. Always use caution when working around electricity, and if you're ever unsure about something, don't hesitate to call a qualified electrician. Remember, a little knowledge can be a powerful tool, but it's essential to use that knowledge responsibly. By following safe practices and using the information in this essay wisely, you can keep your home safe and your electrical system running smoothly.